Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilmi bin Muhammad Rosli. So today I will present about my FYP with the title of the development of the new method to estimate the peak runoff flow. So my supervisor for this FYP is Professor Dr. Abdullah Al-Mamun. And we go to the introduction. So for the introduction, as an overview, the flow through a channel due to rainfall contains the components we are direct runoff flow and base flow. So for my FYP is to study about the estimation of peak runoff flow. So this can be found in various methods to estimate the peak runoff flow. So the problem statement for this title is the application of rational method in the estimation of peak runoff flow has certain limitation, such as they don't include the catchment slope, the surface runoff, and etc. So I will study more about the various parameters that will influence the peak runoff flow. So my objective of this FYP is, the first one is to investigate the effect of various parameters such as catchment slope, rainfall intensity, area of catchment, and flow length in a lab scale physical catchment. So we'll use a lab scale to do our experiments, not a field experiment. Second one is to develop an improvement on a formula for more accurate estimation of peak runoff flow. The third one is to validate the new equation. So when we want to do a new equation, we have to validate that equation. Second is the literature review. So in this literature review, I studied a lot of others method that existing method to estimate the peak runoff flow. So we can see here there's so many, such as hydrological procedure number 5, number 11, Cream's model, Few et al., Kramer's method, and others. So for the methodology of the studies is, the first thing is we have to identify what are the parameters that involved in this study. So for example, I will explain the parameter that we use in the study in the next slide. So this after we identify the studies, we have to choose and then set up the experiment, record the result, and then repeat again the flow. The flow is the same. And I use for the method for the estimation, we use the rainfall hydrograph apparatus, which is the rainfall simulator. So this is the rainfall simulator. We set up the rainfall simulator, and then we have some modifications, such as we put the pitch board to make sure that the surface is very flat, and we put a yellow board to make sure that all the water is coming to the collector. So this is the parameter that I choose for this study. The first one is the slope catchment. So we change the slope from 5 to 15 to 10 to 20, and then we have the rainfall intensity. We have 31, 15, 6, 77, 91, and 99. For the flow length, we change to be 75 centimeter, 105, and also 135. And the last one is the area of catchment. We set the catchment to be 0.3 meter cube, meter square, 0.6, and 0.9. So the result after we do the several experiment, these are the result. We can see the relationship between every single changes of parameter versus the peak runoff flow. So the relationship we can get from the analysis of linear regression. We can see that for the relationship of slope versus peak runoff flow, the R square is 0.26, which is quite good of relationship. They have correlation. For the rainfall intensity, we have 0.5, which is more higher, and then we have flow length with the R square value of 0.5 also, and we have the last one is area, which they are value of 0.4, which is good and show that they have relationship and influence towards the peak flow. And after that, we do the multiple regression to produce the final new equation. So after we do the multiple regression, these are the formula that we get. We have all the parameters such as slope, rainfall intensity, length, and also the area. To validate the new equation, we use several methods. The first one is the adjust R square value. The adjust R square value shows here 0.86. This means that 86% of the estimations can be calculated by using the new equation. Second is we compare the predicted value with the actual value. So we can see from the graph here, the predicted value and also the actual value are quite similar. So this is show that the new equation is quite good. Secondly is we compare with the existing equation. So we take several others existing equations such as Few et al, rational method, and also HP number 5. So from the graph here, we can see that the new equation have a bit higher value compared to others, but there's not too far value. So this shows that they are still acceptable, and also the new equation can be used to estimate the peak run flow. And the last one is we use the mean absolute error. So mean absolute error here, the lesser the value, it shows that the lesser the error of the equation is mean that it's close to the actual value. The predicted value is close to the actual value. So the MA value for new equation is, we can see from the table here, is the least value, which is 0.000001 compared to others, which is more higher. So this shows the new equation is much more closer to the actual value. Lastly is the conclusion and also the recommendation. So as the conclusion, I can say that the objective of the studies were achieved. So the model of regression can explain about 86% of the variation of the dependent variable for the study, just like I explained just now. So the MA value for the new equation give the lowest value compared to others existing equation. This shows that this is the more accurate and also more precise formula compared to the other existing, that more closer to the actual value of the experiment. And the last one is the recommendation. So with a certain limitation of rainfall runoff simulator, that we need more further modification and also improvement that could make the result more accurate and also more precise. So for example, that we can make the duration of storm could be more further longer, and also the nozzle of the valve could be improved to make the spread of rainfall more evenly and more nicely. And the last one is the type of surface could be varying from others type, because in my experiments, we just make the flat surface. So I think that's all from me. Thank you.